Alright, today I want to talk more about slope. Let's talk about the actual definition of slope. Remember, slope is also can be called rate of change. So we've got different ways we can call slope. So slope can also be called rate of change. I like to think of it as the tilt of a line. My pen is slow today. You can also think about it if you're thinking about like a roof. The pitch of a roof is the slope of the roof. And then a lot of times when we're talking about algebra, we'll be talking about rise over run, where we're talking about the difference in the y's over the difference in the x's. So let's look at how you find slope when I give you a line. Remember, we've talked about before, the standard form of a line is where you have your x and your y on the left side of the equal sign and your constant number on the right. That's the standard form of a line. If I have the equation solved for y, then I have now put that form into what we call slope-intercept. So the equation is solved for y. That puts it in the slope-intercept form of the equation. And here's what we know from slope-intercept. This m right here that's in front of the x, I don't know why my line keeps disappearing, m stands for the slope. And it's just that number, not the x. Then the b is my y-intercept. And if you'll remember, the y-intercept is where you touch the y-axis. Alright, so let's look at some equations. And the equations have to be solved for y for you to be able to tell those two pieces of information, the slope and the y-intercept. So if I'm looking at y equals 3.1x minus 4.6, I'm not asking you to do anything with this one except identify these two parts. The slope would be the number that's with my x, the 3.1. The y-intercept would be negative 4.6, and it's negative because I have a negative right there in front of that 4.6. Okay? Everybody understand? Let's look at the next one. In this one, I've got it solved for y. The number in front of the x is 5, so that means my slope is 5. And my y-intercept, I do not have a number out here that's a constant number, so my y-intercept would be 0. Now, let me talk about writing these y-intercepts as ordered pairs. I really should have written this as 0, negative 4.6. Sometimes you can just answer negative 4.6 and the computer will take it. Sometimes it wants an ordered pair. So in this one, if it's a y-intercept of 0, then that means it's 0, 0, or the origin. Now this next one, I've got y equals 5. So I don't have an x part. So there's no x part. That means I have no slope. My y-intercept is the constant, so that would be 0, 5, or you could just put 5 if you're asked for just a number. Alright, identify the slope and y-intercept if they exist. So here I've got, let's look at the left side first. We've got y equals negative x. So this is solved for y. I have an imaginary negative 1 in front of that x, so that I could rewrite that as negative 1x. So that means that my slope is negative 1 right here. I do not have a number outside of the x, a constant number, so my y-intercept would be 0, 0, just like the one we did above. So now this next one, this is not solved for y. It's actually not solved for any x either. There is no y in here. So let's solve it for x, because that really seems to be the only thing we can do. So x equals 5 when I add 4 to both sides. Now on this one, if I've got slope and y-intercept, this one's solved for x. So let's think about this. We've done these before where we have had just x equals a number or y equals a number. And if we had x equals a number, we mark that number on my x-axis, 4, 5. And if you'll remember, since I don't have a y, this graph would be a vertical line at x equals 5. So now let's think about that. Do you remember what the slope is on a vertical line? Well, the slope is undefined because it is it's just messing up. It's undefined because it is a vertical line. If it were a horizontal line, it would have no slope or 0 slope in the example above, y equals 5. Now, for y-intercept, do I touch the y-axis? Remember, this is my y-axis, this is my x-axis. I don't touch the y-axis at all, so there's no y-intercept either here. So this one was just odd because it didn't have a slope really, and it did not have a y-intercept. All right, let's look at the next page. So again, here we have the standard form of a line, ax plus by equals c. Slope-intercept form, y equals, you always need to solve for y. The m is my slope. The b is my y-intercept. And I'm going to write it 0, comma, b, so we don't forget to write it as an ordered pair. So here are some other things that we have learned in this chapter, that if we have y equals mx plus b, again 0b is the y-intercept, m is the slope. This was in an earlier section. We talked about finding the slope of 2 points. So we talked about finding the slope of 2 points and how we put in y2 minus y1 over x2 minus x1. So those are some things we've done with slope so far. Now let's talk about how do we graph if we know the slope and the y-intercept. And to me, this is my favorite way to graph because it's a counting method. And you just have to be able to mark one of your points, and then we're going to count from that point on. So when you see fractions in these problems, do not be alarmed, because the fraction is just going to be a counting fraction. It's not really going to be something where we have to find a greatest common factor and things like that. So if I'm going to graph using the equation y equals negative 3/4 x minus 1, here's what I'm going to need to do. I need to identify what is my slope. And in this case, my slope is negative 3/4, and I need to identify my y-intercept, and my y-intercept is 0, negative 1. Now the way we graph using slope and y-intercept is we mark the y-intercept first. So I'm going to come over here and I'm going to mark 0, negative 1. And then we are going to count rise over run with my slope. So if I've got negative 3/4, that would be rise over run. And incidentally, I write these things on when I do problems. Each time I do a problem, I write the slope, I write rise over run next to it, and then I mark the y-intercept, and I do all of this when I do these problems, and I've been doing them for a very long time. So on negative 3/4, this means that if I have a negative, I always put it with the top number. I need to, instead of rising, I'm really going to fall, and I'm going to fall 3 slots down from my y-intercept. So 1, 2, 3. I'm not going to make a mark there. I'm just going to kind of hover above it. And then my slope says to run 4. So run to the right, 1, 2, 3, 4, and make a mark. And then connect those dots. And so there I have my line that I graphed, negative 3/4 x minus 1. Again, mark your y-intercept, which was 0, negative 1. Remember, that's on the y-axis. And then count your slope. And if it's negative, count down 2, 3. And then run right. 1, 2, 3, 4. Mark your point and draw your line. All right, let's do another one. Okay, here we've got y equals 3x plus 2. So my slope is 3, and I'm going to make it 3/1, because remember I need to count rise over run. My y-intercept is the 2, so that's 0, 2. Now, something else you need to keep in mind, these have to be solved for y. So make sure if it's not already solved for y, that you do so. So far we've had all of them solved for y. So we mark the y-intercept first. 0, 2 would be up here at 2 on the y-axis. This time my rise is positive, so I'm going to go up 3 over 1. So I'm going to go up 1, 2, 3, over to the right 1, mark that point, and connect my dots. And it's as easy as that. Okay. There's an example here on the left side that you can go by. Let's look at the one that's on the right. I've got y equals negative 2/3 x minus 2, so it's already solved for y. Great, great. So my slope is negative 2 over 3. My rise over my run. My y-intercept is 0, negative 2. So always mark your y-intercept first. Oh, you're going to go 0 down to negative 2. And then again on this one, my rise is a negative number, so I need to actually go down and then over 3. So I'm going to go down 2 and then over 1, 2, 3. I didn't mean to make that mark. Let me erase that mark so it doesn't confuse you later. Down 2 and over 1, 2, 3. Make the mark and connect. No table, just identify those 2 points. Now, the only thing that can be difficult is if it's not solved for y, and we'll manage those. We can get our equation solved for y if we need to. So let's talk a little bit about parallel and perpendicular, or neither. We've talked a little bit about parallel and perpendicular before. Remember, parallel lines have the same slope. Perpendicular lines have negative reciprocal slopes. And neither just means neither one of those cases exists. So neither happens. So if I've got y equals 2/3 x minus 4, y equals 2/3 x plus 2, determine if they're parallel, perpendicular, or neither. Well, slope is 2/3, slope is 2/3. The slope is the same. So that means they are parallel. Okay? Over here on this next one, 4x plus 2y equals 2. I don't know what the slope is on either one of these because they're not solved for y. So I'm going to solve this one for y. So I'm going to subtract 4x from both sides. So that's going to give me 2y equals, I'm going to write the x part first, and so it's negative 4x plus 2. Divide everything by 2. So y equals 4 over 2, negative 4 over 2 reduces to negative 2x. 2 divided by 2 is a plus 1. Okay, so there's 1. I'm going to solve this one for y, so I'm going to subtract 3x. So 6y equals negative 3x plus 4. Divide by 6. Come down here, so y equals negative 3 over 6 reduces to negative 1/2 x plus 4 over 6 reduces to 2/3. So negative 1/2 and negative 2, those are reciprocals of each other. If you flipped them over, they're reciprocals, but not negative reciprocals. Remember, negative reciprocals, you have to flip it over and change its sign. So this one would be neither. because they're not the same and they're not exactly negative reciprocals of each other. Alright, so I'm going to sketch, I think this graph was meant for this next one, so I'm going to just sketch this next one. If I've got y equals 4, okay, there's my x and y axis. So y equals 4 would be 1, 2, 3, 4. This is going to be a line that is horizontal through 4 on my y-axis. For the second line, I need to solve it for x. So x equals 3. So that's 1, 2, 3. And that's going to be a vertical line through x equals 3. If you'll look at these two lines, they are perpendicular to each other because one is strictly horizontal, one is strictly vertical. So these are perpendicular. Sometimes on those x equals a number, y equals a number, in fact, if those are the two choices you have, x equals a number and y equals a number, and those are the two lines, they're going to be perpendicular every time. Alright, so let's look at this other example down at the bottom of the page. Alright, they're not solved for y, so let's solve them for y. So negative 3x from both sides. So negative 4y equals negative 3x plus 12. I'm going to divide everything by negative 4. So that gives me y equals, now 3/4 doesn't reduce at all, but the two negatives cancel each other out. So that's going to be positive 3/4 x minus, because 12 divided by negative 4 is negative 3. Okay, so 3/4 x minus 3. On this one, I just need to divide everything by 4. So y equals 3/4 x plus 5/4. Now you can see I've got 3/4 x, 3/4 x, so 3/4 is the same slope. So they're the same exact number, they're the same sign, same fraction, so that means they are parallel. Those are parallel lines. Alright, so what if I asked you to write an equation given the slope and the y-intercept? Well, remember my slope is m and my y-intercept is the b. And so remember, I wanted in the form y equals mx plus b. So I'm going to write y equals, if m is 4/5, so that's 4/5 x, don't forget to put the x in there, and don't forget to put the y. And then my b is a plus 3, so I put plus 3, just like that. Okay, in this next example, if I have the slope is negative 2/3 and the point is 0, 6, so negative 2/3 is my m, the 6 is my b, so y equals negative 2/3 x plus 6. And it's as easy as that. Okay, use slope-intercept form to determine an equation of a line given a point on the line and a slope. So if we're going to mark the, it's going to have a point at negative 4 negative 4, 3. So negative 1, 2, 3, 4, up 1, 2, 3. And then it's telling me my slope is negative 2. So I'm going to write that as negative 2 over 1 rise over run. So that means that I'm not going to go up 2 and over 1. I'm going to go down 2 over 1. So go down 2 over 1. Let's do that one more time. Go down 2 over 1. Just like that. So there is my line. Okay, so write the slope-intercept form to use an equation. So I need to know what the y-intercept is, and if you'll see down here where I drew my line, that y-intercept is at -4. That's where I end up hitting the y-axis. So 0, -4. So y equals, my slope was -2. I've got that in the problem. So -2x. And then my y-intercept was down at a -4. So that would be -4. And that's how you write the slope-intercept form. You just need to draw it out and find your y-intercept. And that's how we graph using slope and y-intercept. Have a great day.